So in this sense, when we talk about values, we're talking about our inherent values. Do we value the format of the test? Do we value the information that it provides? We also have to consider what are the consequences of our interpretations. Because I work in special education, you have to really consider in those scenarios, if you're making a diagnostic or a placement decision, what are the consequences of interpreting information in a specific way? You may be determining a student's placement or determining whether or not they're eligible to receive services. So the consequences of whether or not the use is valid for that particular student has to be taken into account. When we talk about assessments that are constructed, created, and designed by teachers, there are also some guidelines related to validity. We want to make sure that the content is representative of things that we've actually taught in the classroom. So the content of the instrument itself, whatever we're using to actually assess the students, is representative of the teaching that we've done and that is relevant to the students' lives. We also want to see if the instrument that we've constructed requires them to use thinking processes and skills that are appropriate and that we would like to take into consideration. Our instruments need to be consistent with other classroom assessments that we may be using. We want to make sure that our instruments are reliable or produce the same results if they're administered a second or third time, and that they're objective rather than subjective. Our instruments need to be fair to different types of students. Have we taken into account ethnic and cultural differences so that our test is not inherently biased? Is it fair to different types of students taking the test? Is the test exemplary of economy, efficiency, and practicality? Are we using multiple pieces of assessment information to make important and informed decisions? And do our teacher-made tests have positive consequences for learning? Does it give us important feedback about where the student is in relation to the content? And does it give the student some feedback about the same information, where they are, and also what can they do to further their learning and to improve? In talking about validity, one of the things that we often examine is what's called a correlation coefficient. This coefficient is a number that gives us an idea of the relationship between two different variables. So it quantifies the degree of the relationship between two variables. Correlation coefficients are always on a scale of -1 to +1. So a coefficient is going to fall somewhere between -1 and +1. The negative or the positive tells us the direction of the relationship. So for example, a -1, if we're looking at a relationship between two variables and the coefficient is -1, then we know that that relationship is a negative relationship. So as scores on one variable go up, scores on the other variable go down. A positive relationship indicates that as scores go up on one variable, scores on the other variable also go up. It is very rare to have a perfect correlation between two pieces of information or two variables. More likely, you're going to get something like -0.59 or +0.81. Those numbers indicate overall the general direction of the relationship between two variables. One way of examining correlation coefficients is to actually plot your variables and to look at them on what's called a scattergram or a scatter plot, or sometimes called a scatter diagram. So for example, if we look at this correlation here, you see that the scores, the high scores on the variable that's on the x-axis are associated with high scores on the variable on the y-axis. So as scores on one instrument go up, the scores on the other instrument also go up. These two variables are showing a positive correlation. This is a negative correlation. Here you can see these individual dots are an individual student. So when you're creating a scatter plot, you look at what the student scored on variable X, which is down here on the bottom. So let's say that's a math test. And this particular student scored an 8. Over here, if we have a reading test, that particular student scored a 2 on the reading test. So as scores on one went up, scores on the other went down. If you have a perfectly straight line here, then it would mean that your correlation is perfect, or it would be a -1. Much more frequently, you're going to have kind of this scatter of dots, but you're looking for an overall general trend. So you can see here that overall, the general trend is a negative correlation. You also can have a scatter plot that looks like this. A scatter plot that looks like this is indicative of a coefficient that is a 0 or no relationship, or very close to 0. So you may have a decimal number, but that number is going to be very close to 0. We know that because the data points within the scatter plot are all over the place. There's no overall trend. It's important to remember that correlation does not equal causation. So if our scatter plot and our correlation coefficients support the conclusion that two variables are related, either through a negative correlation or a positive correlation, it does not mean that one causes the other. The only thing that you can interpret from that is that the two variables are related, not that one causes the other. Reliability is the degree to which students' results remain consistent over replications of an assessment procedure. So an instrument is considered to be reliable if it yields the same results for the same student over time. It's important to keep in mind that just because an instrument is reliable does not mean that it's valid. It doesn't mean that it's testing what we want it to test, or that our interpretations are appropriate. However, an instrument must be reliable before we can consider it to be valid. So it's a necessary but not sufficient piece of evidence to support the conclusion that how we're using and how we're interpreting test scores is valid, or the quality of our decision making. It's very important in discussions of reliability to consider error. Error is always going to be present within any assessment procedure. You're always going to have some level of error. You can kind of think of it as we never really get a completely accurate picture of a student's level of knowledge. What we can try to do is we can try to get as close as we possibly can to that elusive number, and we do that by reducing error. So we can control error to some degree. We can reduce error by crafting really solid assessment instruments and setting up assessment situations that facilitate accurate pictures. However, we're never going to know exactly what the student's true performance is. In that same vein, we have to remember that one score that we get is the obtained score. That score always has to be added to error in order to think about that true score. Now, we do have statistics that allow us to statistically compute based on different mathematical equations and numbers what that true score is likely to be. That is well beyond the scope of this particular course. So it's just important for you to know that obtained score plus error equals your true score. And that drives home the fact that when we get a score for any particular student, we have to take into account that that score has some level of error within it. And that affects how we interpret and use that information. Standard error of measure, or SEM, is an estimate of the standard deviation of the errors of measurement. So it gives us an overall picture within a particular instrument of the average error of measurement. It helps us understand how big is measurement error. And this is not necessarily going to come into play with a teacher crafted assessment instrument. It is, however, going to come into play when you're using a more large scale standardized instrument. And standard error of measure should be given within the testing manual in those situations. As you think about reliability and validity, one of the things that you also need to think about is how can you improve reliability of assessment results? How can you ensure that the information that you're obtaining is the best information that you can get while understanding it will never be perfect? There's really two layers to this. The first layer is thinking about how to design tests, teacher-made tests, and other instruments that are good, strong instruments. The second layer is thinking about the actual administration of the instruments. I think the video that is also embedded within this module really highlights how the testing environment can also impact error. As you read through the content in your text, pay particular attention to things that you can do as a teacher to improve the reliability and validity of your assessment results.